Okay, this is my lab report for lines of charges. A quick overview of this video report: I'll introduce the experiment and relevant physics principles, the calculations and code for the experiment, and then conclude with some further questions. So the goal of this lab was to calculate the amount of excess or deficient charge on a piece of Scotch tape with a more accurate model of charge distribution than that used in Lab 1. So two tapes were given an equal charge distribution after being stuck together and then pulled apart. And using a negatively charged pen, we were able to determine that this net charge was positive, or that there was a deficiency of electrons on the tapes. Then one tape was floated over the other. The force of gravity on the top tape was equal and opposite to the electrostatic force of repulsion from the bottom tape on the top tape. And then using Newton's laws, I was able to calculate the charge on the tape from the results of the experiment, which came out to be roughly 8.32 times 10 to the negative 9 coulombs. Some important underlying physics principles in this lab are shown here. The key difference from Lab 1 is substituting Coulomb's law, which approximates forces on and from 2-point charges, for the estimation of a line of charge, or a series of point charges which span the length of the tape. This more accurately resembles the real-world situation where charges would be spread out across the surface of the tapes. Then we can use the superposition principle, which allows us to add individual electric fields from each charge in the line to get one net electric field vector. Then we can employ Newton's laws, which tell us that the sum of the forces in the y direction which act on the top tape sum to 0, since the top tape experiences no acceleration, so F equals 0. Therefore, the net electric force and gravitational forces are equal in magnitude and opposite in direction. So these are some preliminary calculations based on the diagram I showed on the slides before, which you can pause to see. I performed my calculations in GlowScript. The code is pictured here. Here is the code for calculating the electric field from one of the point charges in the line. And then we have the code to model the electric field from every charge in the line, which employs for loops. These arrows for the electric field vectors are shown here. The tapes are modeled as a line of spherical charges in red and blue, and then the net electric force in white is seen here as equal and opposite to the force of gravity on the tape in yellow. Some other important assumptions and simplifications for the lab: we assume there are no other forces acting on tape B in the y direction, which allows us to set the force of gravity equal to the electrostatic force. So we assume the effects of something like air resistance on the top tape are negligent. We also assume that each tape had equal amounts of charge. Comparing these results to Lab 1, we can see both methods result in very different values for the total charge on each tape. I'd say the line of charges model is a better approximation of the total charge on the tapes, since it more accurately models the real-life distribution of charges, which would be on the surface of the entire length of tape.